So, have you ever tried to copy a drawing, maybe make it a little bigger, but you just can't get the proportions right? It is so much harder than it looks. Well, what if I told you there's this simple, kind of elegant mechanical tool that has a secret? A hidden mathematical power that lets it do this perfectly, every single time. Yeah, let's dig in and uncover the magic of the pantograph.
All right, let's kick things off with a bit of a mystery. Just look at this thing. At first glance, it's really just a simple collection of linked bars. But believe it or not, it's designed to do something surprisingly complex and with incredible precision. Any ideas what it might be?
Okay, so here's the real challenge, right? Forget about your modern scanners or photocopiers for a second. Imagine using only mechanics, just levers and joints, to trace an image and have a second pen perfectly copy it, but at a different size. I mean, the slightest mistake would totally warp the copy, so the accuracy has to be, well, perfect. And here's the answer. This clever little device is called a pantograph. Now, you might see an old one in a vintage drafting set, maybe even find one at a hardware store. But what's really cool is that today you can actually 3D print your own. You can literally hold this mathematical magic right in your hands.
Okay, so how does this thing actually work? Let's see this little mechanical artist in action.
Just watch this thing go. As one pen traces those smaller letters, the other one, which is mechanically linked of course, draws a bigger, perfectly proportioned version. And the amazing part is, this works for any shape you can think of, whether it's complicated curves or just your own handwriting.
And this is a fantastic illustration of its main job. It doesn't matter if you're scaling up a small circle into a big one or, doing the reverse and shrinking a drawing down. The proportions are always, always perfect. The shape stays exactly the same, just a different size.
Getting started is super simple. You just fix one point to your table or drawing board, grab two pens, and you're set. As you trace the original with one pen, the other just automatically draws the copy. And hey, here's a little pro tip for you. If you use graph paper, you can really see that perfect geometry working its magic, square by square.
So, the big question, how does this mechanical magic actually work? Well, the secret it's not magic. It's just pure, elegant geometry. So let's peel back the curtain and see the math that makes this whole thing tick.
The whole thing, the entire device, is built on one core idea: similar triangles. Now, what are those? They're basically triangles that have the exact same shape, the same angles, but they're different sizes. And the key thing to remember, the really crucial point, is that the ratio between their matching sides is always, always constant. And here's the proof, right in the design itself. Just look at it. What do you see? Parallel lines, right? Well, those lines create two nested similar triangles. You've got the smaller one, OAB, and the bigger one, ODE. Because they're always locked together in this way, the ratio between their sides never changes. It's constant. That's exactly what that formula on the screen is showing us. It's the geometric rule that guarantees every single movement is scaled perfectly. It's pretty genius, actually.
So really, when you think about it, it's both geometry and algebra, isn't it? You have the tool using the visual side of things, the geometry, the triangles, to perfectly carry out the rules of algebra, the proportions. It's a physical object that literally behaves like a living, moving mathematical equation. This little simulation makes it even clearer. See that fixed pivot point? That plus the parallel bars creates a constraint, a rule. So as the tracing point moves along the smaller shape, the drawing point is forced to follow a path that's mathematically identical, just bigger. It literally has no other choice. The geometry dictates everything.
And this isn't just some dusty old antique, The Pantograph is an absolutely fantastic, hands-on tool for learning. And the best part is, thanks to 3D printing, it's more accessible now than it has ever been.
What's so brilliant about these modern 3D printed designs is that they print all in one go. The whole thing, hinge, joints, and all, comes out ready to use. It makes them these amazing, hands-on tools for a classroom or just for fun at home. It really helps you get a gut feeling for how proportions and geometry actually work.
Now, unlike some of the older adjustable models, these 3D printed ones are a little different. They're designed with specific fixed scale factors built right into their geometry. So you just print the one you need for the job.
So, for example, you can print a version that will perfectly double the size of your drawing.
Or hey, maybe you need one that scales it up by 2.5 times.
Or even one that triples its size. And every single one has that perfect mathematically guaranteed accuracy baked right in. And here you can see a few of them together. Each one has its proportions locked in, all ready for a specific scaling job. It's just a beautiful example of how a physical design can bring a mathematical rule to life.
So, when it all comes down to it, the pantograph is so much more than just a drawing tool, isn't it? It's this powerful reminder that really complex mathematical ideas are often hiding in plain sight, embedded in the simple things we use every single day. And that brings me to a final question for you. Now that we've seen the hidden geometry in this simple little drawing tool, what other everyday objects can you find that are this mathematically rich? I mean, really, take a look around you. The answer, well, it just might surprise you.